All right, so we're going to be doing trig with special right triangles today. So our warm-up is just a reminder of what to do with some radicals. So if we want to simplify 12 square root 3, we have to first rationalize the denominator because we do not want to have any radicals in the denominator. So we were going to multiply by the square root of 3. And if we do it to the bottom, we have to do it to the top. And the reason why we want to do that is because square root 3 times square root 3, this together is the square root of 9 because you just multiply the numbers together. And then the square root of 9 is just 3. So then you have 12 square root 3 over 3. And then 12 and 3 can simplify. That'd become a 1, and that'd become a 4. So then our answer would be 4 square root of 3. For the second one, we don't have to rationalize the denominator this time, but we do have that square root 2 that we have to deal, or square root 20 that we have to deal with. So with that square root 20, you're going to come out to the side. Square root 20 breaks down into the square root of 4 times 5. Now, if you stop and say, hey, I know that 4 is the square root of 2, or the square root of 4 is 2, then you can be done and you can write as 2 square root of 5, and you already have it. If you don't see your perfect squares quite as easily, then you will want to keep breaking it down so that it becomes 2 times 2 times 5. And again, if you're not good with those perfect square roots, you're just going to break it down as far as you can and then look for pairs. So because I have a pair of 2's, they get to move outside of the radical. So then it would still be 2 square root 5. So then square root of 20 is 2 square root 5, and then it's still over 2. We can simplify again with those 2's. So then it just becomes the square root of 5. Okay. So those dealing with radicals is going to be happening a bunch with this today. So you just kind of got to, it's a good time to practice your radicals. So starting off, we're going to have the sine of 30, and we're going to do all of the trig for sine of, or sorry, for the 30 degrees and all the trig for the 60 degrees. So if we're looking at this 30 degrees, labeling the sides, this square root 3 is my adjacent, 1 is my opposite, and 2 is my hypotenuse. So sine of 30, remember we still have SOHCAHTOA, that doesn't disappear. Sine is opposite over hypotenuse, so my opposite is 1 and my hypotenuse is 2, so it's just 1/2. So that one's nice and simple. For cosine of 30, it is adjacent over hypotenuse. So my adjacent is square root 3, and my hypotenuse is 2. Let me make that 3 a little bit better. Boop, there we go. Okay, so cosine of 30 is always the square root of 3 over 2. Something that's important to realize too is that we are not going to be using decimals for this. We want to keep the radicals and everything. So your answers should all end up as fractions or radicals. So then tangent of 30 is opposite over adjacent. So then opposite is 1, adjacent is square root 3, and this is why we reviewed rationalizing the denominator. We need to multiply by the square root of 3, and square root of 3. So when we do that, square root 3 times the square root of 3, that doesn't even look like a 3, I'm slacking. There you go, is square root of 9, and the square root of 9 is just 3. So we have square root 3 over 3. Okay, so then for 60 degrees, I'm going to get rid of my little labels here. I'm going to keep my hypotenuse because that doesn't change. But sine of 60, now the square root 3 is my opposite, and this one is my adjacent. So if I want the sine of 60, it is opposite over hypotenuse. So my opposite is square root 3, and my hypotenuse is 2. For cosine of 60, it is adjacent over hypotenuse. So my adjacent is 1 over hypotenuse of 2. And then tangent of 60 is opposite over adjacent. So opposite, square root 3. Adjacent is 1. So it's just the square root of 3. Okay, now you're going to want to be able to remember these trig ratios for these special right triangles. And I do have a trick using your hand that can help you. So I'll probably end up making another video to kind of lay all that out there to make it a little bit easier for you, but that'll come later. So looking at 45 degrees, now we're going to look at our next one. Notice with both of these being 45, it doesn't matter if I'm doing sine or cosine because my opposite and my adjacent for both is going to be 1. So if I'm doing sine of 45 for the purpose of picking an angle, because we always pick an angle, I'm just going to pick the one on the bottom. So then the sine of 45 is 1 over square root 2. But, we got our no-no. We can't have that radical in the denominator. So we're going to multiply by the square root of 2. So then 1 times square root 2 is just square root of 2 over. And then square root 2 times square root 2 is the square root of 4, which square root of 4 is just 2. So sine of 45 is square root 2 over 2. For cosine, we're going to have 1 over the square root of 2 again because adjacent over hypotenuse is going to be the same. So when we multiply by the square root of 2 again, wouldn't you know, we get the exact same thing we just got. What a surprise. So cosine and sine of 45 is actually square root 2 over 2 for both of them. And then for tangent of 45 is just 1 over 1 because it's opposite of 1 over adjacent of 1. So then the tangent is just 1. And tangent is actually, fun fact, also sine over cosine. So if you know that your sine and your cosine are the same, then you know it's going to be 1. And that can help you when you're doing your tangent of 30s and 60s too if you want to use it later. So first, we're going to solve for x just like we used to do way back in the good old days. So if I want to solve for x, I'm going to use this angle, and I'm going to have my opposite and my hypotenuse. So I'm going to have sine of 45 equals opposite over hypotenuse. And when we did this in the past, you would multiply by multiply by your denominator, 16 times 16, and 16 times sine 45 equals x. And 16 times the sine of 45, I am unprepared and do not have my calculator handy, so let me pull it out real quick. So with a calculator on my phone, 16 times sine of 45 is 11.31. And that's how we were solving it before, and we were perfectly content that way. But now we're not quite as perfectly content as we were. So now we're going to have to go back to the Stone Ages where now we don't have a calculator handy. I know for some of you you're like, but I always have a calculator. But I'm sorry, we're going to have to deal with it. So if you are not allowed to use a calculator, the main thing we need the calculator for is that sine of 45, right? Because most of us just don't go, hey, sine of 45 is this decimal. So since sine of 45 is not something that we just regularly know, this is where you want to actually, it makes it much easier if you know what sine, cosine, and tangent are for your special right triangle angles, so 30, 60, and 45. So sine of 45, we found out earlier, is the square root 2 over 2. So if sine of 45 is that value, well, then we can just substitute it in. That's math magic happening right there. We always substitute things in when we need it. So we have square root 2 over 2 replaces the sine 45 equals x over 16. So then to solve this, now this is a proportion, which is like what we were doing when we had similar triangles in the first place. So we're going to cross multiply. 2 times x is 2x. And 16 times square root 2, don't overthink it, is literally just going to be 16 times the square root of 2. So then, actually I'm going to highlight that so we remember that we substitute values in. So then to solve this, we're still trying to solve for x just like we were above, but instead of multiplying by 16 and grabbing the calculator, now I'm just going to divide by 2 because kind of what happened, I didn't have my calculator handy to do sine of 45, but I can do this without a calculator. 16 divided by 2 is 8, square root of 2. And then I have my value for x. And if you pull out a calculator and do 8 times the square root of 2, guess what? You're going to get the same answer you just got, except in a decimal form. But for all of this, your answer needs to be in radical form or in a fraction form, okay? So looking at the examples, we are looking at this triangle, and I notice that these little tick marks in here, oops, oh no, It's going crazy. We have these little tick marks in here. And remember, those mean that those angles are congruent. So the only special right triangles we have are 30, 60, 90 or 45, 45, 90. And so since these are the same, I know this is going to be 45 degrees. And you can label it if you want. You don't have to. But since this is 45 degrees, I'm just going to use this angle here. Again, with 45 degree or 45, 45, 90s, it doesn't really matter which 45 you pick. But I'm going to pick that one because then I can say sine of 45 equals, my opposite is 10 square root of 2, and my hypotenuse is x. So opposite, 10 times square root of 2 over x, my hypotenuse. Now, sine of 45, remember, I'm doing this without a calculator because I don't want to have it handy all the time. Sine of 45, go back to your chart. Sine of 45 is that square root 2 over 2 again. Okay, so come back down here. I know sine of 45 is square root 2 over 2, which equals the same thing it just equaled. So we're substituting in values. Okay, so now that we have that, we're going to cross multiply. So x times square root 2 is x times square root 2. And that's going to equal 2 times square root 2, or sorry, 2 times 10 square root 2. So 2 times 10 is 20. And then you just keep the square root 2. So to get x by itself, this is multiplication right now in here. So we're going to divide by the square root of 2. And the nice thing about dealing with radicals is sometimes they'll just magically cancel each other out, and then your answer is a nice pretty one that you want, like x equals 20. And that is actually the answer. So yay, we're done. Okay, so for number 2, we have another 45, 45, 90. So it doesn't matter which 45 angle we base it off of, but since they labeled this one, I'm just going to use that one. So we have sine of 45 equals opposite over hypotenuse, so 8 over x. Sine of 45, remember, I don't have my calculator handy right now. So sine of 45, you're going back to your chart, or if you haven't memorized, you just know it's square root 2 over 2. So x, square root 2 over 2 equals 8 over x. Then, so after we substitute, then we cross multiply. So x times square root 2 is x square root 2, and that is equal to 2 times 8, which is 16. So then, just like before, this is multiplication, so we're going to divide by the square root 2. Unfortunately, even though sometimes we have wonderful times where x equals 20, you also have times where now it's 16 over radical 2. So me personally, I am just going to kind of work off of what I have already. So I'm going to use this green. So I'm going to multiply by square root 2 because I don't want to run out of space right now. So 16 times square root 2 is obviously 16 times square root 2. And then square root of 2 times the square root of 2. Looking at this bottom, that's square root of 4, which is 2. So now you notice that the 16 and the 2 cancel each other out. So that'd be 8 and 1. So my answer is 8 square root of 2. Okay. So now we're going to scroll down to number 3, and we're going to do the same thing. So we have a 30-degree angle. Now with this, you're either going to keep the same angle and change your trig, or you can keep your same trig and change the angle. So what I mean by that is if we start with this 30 degrees, I can do sine of 30, set it up, and cosine of 30, and it'll get me x and y. Or I can do sine of 30 to get x, and then I can use sine of 60. So notice I kept sine for both of them, just change it to the 60 to get the y. So I'll do it both ways through all the examples. So starting with that 30, I'm going to have sine of 30 equals opposite is x over square root 6, which is our hypotenuse. So sine of 30, if you don't know what it is off the top of your head, just go back to the chart. Sine of 30 is 1/2. Okay? Oopsie. So since that is, sorry, I didn't want to make sure that stayed. Since sine of 30 is 1/2, we're just going to come down back to where we were. Sine of 30 is 1/2. and that equals x over square root 6. So then to solve it, we're going to cross multiply just like we were doing. So boot times this. So we have 2x equals 1 times square root 6, which just gives us square root 6. And then we're going to divide by 2. So then x equals the square root of 6 over 2. And even though it seems like that should be able to simplify, because that 6 is in the radical, we can't do anything. We're just kind of stuck with square root 6 over 2. So then to find y, we're going to do the same thing, except now to find y, we're going to use cosine. So cosine of 30 equals y over square root 6. So you notice I kept the same angle and just changed from sine to cosine. So that is one major way to do it. Boop. No, trying to get rid of it. Oh, no, I got rid of the 0. So cosine of 30, if you don't know it, scroll up to the top. Okay, cosine of 30 is square root 3 over 2. So square root 3 over 2 equals y over square root 6. So then you cross multiply. Oops, let me use my different color. Let's keep the pattern going. So we have 2 times y, which is 2y. And then square root of 3 times the square root of 6 is really just the square root of 3 times 6, which is the square root of 18. So then we divide by 2. And some of you may prefer to simplify a radical first and then divide by 2. It's kind of up to you. Square root of 18 does simplify, and I don't want to run out of space, so I'm going to put it up here. So square root of 18 breaks down into square root of 9 times 2. So 9 is my perfect root. So I would get, actually I'm just going to write it up here. Square root of 9 is 3. And then the square root 2 has to stay. And then that is over 2 still, because remember, we're just substituting in that value for, we're just finding what the square root of 18 simplified to. So, and if you need arrows, boop, 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 boop. Okay, so whenever you're doing these, you really just are going to have to refer to the table to see your best way to go about doing it. So let's see if I can draw some boundary lines for myself. Looks like a crayon though. Oh well. All right, so looking at number 4, we're going to start, and this time I will just use, I'll switch the angles and keep the same. So, or keep the same trick. So I'm going to start with sine of 30. So sine of 30 is opposite x over hypotenuse 44. So then sine of 30, I already know, is 1/2 equals x over 44. And then we will cross multiply. So we have 2x equals 44. And then when we divide by 2, x equals 22. Okay, so yay, we got one of our pretty answers that came out all nice. But if I want to change the angle, keep the trig, I'm going to do sine of 60 now, because now, oopsie, 60, we're up here, is y over 44. So I just want to take a second, make sure you realize that I did this between 3 and 4, I did it 2 separate ways. In number 3, I kept 30 degrees for both of the angles, but then I moved the sine and the cosine. For number 4, I kept the sine and just changed the 30 and 60. And it's totally up to you how you want to solve it, as long as you're setting up your trig functions right. So sine of 60 is the square root of 3 over 2. And if you don't believe me, check your chart. But it is square root 3 over 2 equals y over 44. So then we will cross multiply. Forgetting to change my colors again. So we have 2y equals 44 times square root of 3. So then to get that y by itself, we have to divide by 2 again. And y equals 22 times the square root of 3. And there is a pattern to the side lengths of these that I can tell you later. But you'll notice that sometimes you'll have answers where that number that you got your pretty answer for is now going to have a radical with it when you get to the other one. And it's a good idea to be aware of all of it if you want to be extra awesome. But I'll show you that at the end. So for this one, Personally, I have a tendency to want to use the same angle every time, so I'm just going to use this 60 degrees. So then I know that this is my opposite, this is my adjacent, and this is my hypotenuse. And this is one reason why I like to use the same angle, because then I can just label my triangle and not have to think anything of it. So if I'm using my 60, I'm going to use sine of 60 to help me find my y. So my opposite, 10 square root 3 over y. So sine of 60, again, is going to be the square root of 3 over 2. If you don't believe me, check your chart. I promise that's what it is. So we have square root 3 over 2 equals 10 times square root 3 divided by y. So when we cross multiply, we have y times square root 3. 2 times 10 is 20 square root 3. So then, because the y is getting multiplied to that radical 3, we're going to divide by the square root of 3. So we have y equals, that cancels out to just be 20. Yay, I love when that happens. Okay, and then if I want to find x, now I'm going to use cosine because x is adjacent. Cosine of 60 equals x over, actually, I don't want to use cosine. Silly me. The problem with using cosine is if I use cosine, I'm doing adjacent over hypotenuse, and then I have to use the value that I got, which I guess this is a whole number, so it's really not the end of the world. I have a tendency to want to keep using the same values that they give me just to make sure I'm extra right. So for the purposes of that, I'm going to show you. You can certainly do cosine of 60 and see if it ends up working out the same after. But I'm going to do tangent of 60 instead so that I have my adjacent and opposite. So tangent of 60 is opposite, 10 square root 3 over adjacent. So then with substituting in values, tangent of 60 is sine over cosine, so it should be square root, and I'm just double checking because sometimes tangent gives me iffy. Tangent is just square root of 3 for 60. So tangent of 60 is the square root of 3. And some of you may be freaking out a little bit and say, oh my gosh, I don't have a fraction. Make it a fraction. Put it over 1. So then we cross multiply. We have x times the square root of 3 equals 10 square root of 3. So then we'll divide by that square root 3. And x equals, those cancel out, 10. Yay! And this one ended up having 2 pretty answers. That only happens sometimes. And if you did do it with cosine, cosine would have been, let's see, x over 20. And then we would have had square root 3. Would have still worked out. But again, I always use numbers they give me. So for this one, it's a 45, 45, 90. So I'm going to use this 45 degrees because it's just the one they labeled. So using that, I'm going to have sine of 45 equals opposite. And this one we only have to find 1. Equals opposite over hypotenuse, so 5 over x. Sine of 45, I know, is square root 2 over 2. So then we cross multiply. There I am forgetting my colors again. So we have x times square root 2 equals 10. So we'll divide by the radical 2. And x equals 10 over square root 2. But oh no, I don't like that denominator. I need to rationalize it. So we're going to multiply by the square root of 2 over 2. So then on the top we have 10 square root 2 over square root of 2 times square root of 2 is the square root of 4, which is just 2. So then I notice, hey, wait a second. This will become 5. This will become a 1. So then x is just 5 square root of 2. Yay. Okay. So then, let's see how many more. We got 10. Okay, sweet. So for number 7, we are going to set it up, and I am actually going to be running close on time this time. So I'm going to be doing these kind of fast. So sine of 45 equals x over 9. By the way, feel free to pause this whenever you want. Sine of 45 is square root 2 over 2, and we keep that x over 9. So when we cross multiply, we have 2x equals 9 square root 2. So we'll divide by 2. And then we have x equals 9 square root 2 over 2, which can't be simplified, so that is our answer. Okay. For number 8, if I do sine of 45 again, we have opposite 8 square root 2 over x. Sine of 45 is the square root 2 over 2. So when we cross multiply, I have x square root 2. 2 times 8 is 16 square root 2. So we will divide by the square root of 2 to get it away from the x. And yay, they cancel each other out, and x is just 16. So that one works real nice. All right, so with this one, your hint, because they didn't mark the angles, is that both of these sides are x's, so we know these are 45 degrees angles because they should be the same. So because of that, sine of 45 equals opposite over hypotenuse, which again, sine of 45 is square root 2 over 2. I would recommend always writing what trig function you're using. That way you can at least get partial credit if you mess something up. That way we kind of know, like, where did you come from. So we have 7 times square root 2 equals 2x. So then we divide by 2. And this one doesn't end up being very pretty because we can't simplify, but it is 7 square root 2 over 2. Okay. And then last but not least, we have another beautiful 45-degree angle. So we know this is a 45, 45, 90. So then sine of 45 equals opposite over hypotenuse. So then sine of 45 is square root 2 over 2. So when we cross multiply, you have 2 times the square root of 2 times the square root of 2. Well, square root of 2 times the square root of 2 is the square root of 4. So it'd be like 2 square root 4. But remember, this becomes a 2, so it's really 2 times 2. So it's just 4. Oops, not 4 over 2. 4 equals 2x. And then when you divide by 2, you get that x equals 2. So that wraps up the notes section of this. Just keep in mind that you don't always have to use sine. You don't always have to use specific angles. You can choose if you want to use a 30 or the 60. Feel free to use cosine or tangent, whatever you need based on the questions you are given. And remember, every time you do it, you're going to be setting it up and referring back to the table unless you know the little trick with your hand to do it. So you're going to refer back to sine of 30 is 1/2. Cosine of 30 is square root 3 over 2. And just make sure that you understand that we're substituting in those values rather than pulling out our calculator. So make sure that all of your answers are the not pretty ones. Give me radicals. Give me fractions with radicals, okay? Like number 7, it's okay for your answer to be that yucky. It happens, okay? So good luck. Let me know if you have questions. Yay, trig. Oh no, where did that come from? I don't want that. All right, bye.